Good evening, everyone. Can everyone um, listen to me, hear me, or yeah? Can everyone see my screen as well? Okay, okay, yeah. Thank you. Yeah. So once again, I'll just start my video as well, recording as well. So okay, then I'll start right away. So yeah, welcome everyone to week 9 of the course Research Methodology in Natural Sciences. My name is Arjun. Arjun is V. I am a second year PhD scholar in Indian Institute of Science, Bangalore, and I am one of the TAs for this course. The apart from the other TA who teaches on Tuesdays, this TA session will be happening, as you know already, I guess. This TA session will be happening every Saturday from 3 p.m. to 5 p.m. So let's get started with the TA session right away. So as usual, uh, as it happens for the past 8 weeks, we will have a short recap session of what happened in the lectures of week 9, and followed by that we will proceed towards the problem solving session of week 9, where we will be seeing over the problems of week 9. Yes. So, and one kind suggestion for every participant would be to keep their mic on mute and video also turned off, unless and until you have any doubts. We will be having doubt session in between each segment of this session. So feel free to either ask your doubts right away or reserve your doubts for the TA session as well. So I'll get started. So I get started. So last week in week 8 we saw about um, different statistical tests and different statistical measures to measure, quantify, and prove data. Um, Now some of the statistical tests that we went over were Z-test for normal distribution, and T-test, which is also for normal distribution but for lesser number of observations. And we also saw about chi-square test, uh, where we saw where we had expected and observed values for certain parameters, and we saw whether those change in parameter values was either due to random errors, any random variable, or is it not. So there were different types of statistical tests, and this week we shift completely to a theoretical perspective, or I would say theoretical and mathematical perspective. So half part of this week 9 lectures focus on theoretical research, how postulates are formed, and how uh, a scientific topic starts from a hypothesis and ends up with a result and a mathematical model. And the initial lectures focused on how to build up functional relationships from existing experimental data. So there are like few steps where a scientific question is addressed, a scientific problem is posed, and it is addressed later. And there are some steps as well. And one of the steps is to propose a hypothesis and postulate. So as we saw earlier, like, as we have been seeing for the past 6 7 weeks, scientific materialism focuses on proposing multiple hypotheses and proving and disproving them. So the more you disprove the hypothesis, the more you focus on getting the appropriate correct hypothesis, and you focus on that and you build your theory around it. And so you have to propose a lot of hypotheses and postulates in order to find an answer to your solution. And after that, you would have to continuously work out your experimentally testable predictions. So through your hypothesis, you will have a list of predictions. You would have to design some experiment to uh, arrive at some data which will hint towards your prediction. And using that data, you can find out whether your predictions come to be true or not. Just a second, I'll just confirm once again if this recording is happening. Yeah, it's right. Yeah. So after you kind of get the data, you kind of obtain a functional relationship from experimental data. You have basically you have a bunch of independent variables and some dependent variables. So you try to establish some form of relationship between the independent and dependent variables, which will form a meaningful relationship, and in most times it will end up in the formation of an algebraic expression, which involves the independent and dependent variables. And the last two expressions will be to check consistencies between various theories. So obviously, when you frame a hypothesis and if you find any suitable data which supports the hypothesis, it should be in tandem with existing theories as well. It can't uh, cross question, or it can not more like cross question. It can't disprove or disvalidate any existing correct theories or hypotheses. So whatever theories we come up with, it should be in tandem with that. And finally, after you obtain functional relationships from experimental data, you combine all these functional relationships together and you finally develop a mathematical model which involves the physical phenomena you're trying to question. So, in the initial lectures we saw about this, and after that we saw about least squares fitting. So, in least squares fitting involved a phenomena where we mainly focused on linear fitting, linear regression fitting. So we had a bunch of points which, let's just say we have two variables like y, x and y. We are trying to establish a functional relationship between x and y. That could be done, the relationship could be established in multiple ways and multiple equations. In this part of the lectures, we focused on establishing a linear relationship between x and y, where the relationship is established as y is equal to mx plus b, where m represents the slope of a linear fitting curve and b represents the y-intercept of the slope. So using this equation, a functional relationship is established between x, which is the independent variable, and y, which is the dependent variable. So after that we saw about something called as least squares fitting to find out which is the most optimal m value and b value for the given linear relationship. So how do we do that? So we already have an existing line with random m and b values. We try to come up with error values for y, which is like delta y. If I try to find out how y is varying with the line in question, and then we try to minimize. What we try to do with least squares fitting is we try to find m and b values where this delta y value is very minimal, and with that we also found out how to find out the appropriate m value and b value, which involved a lot of derivation as well, which had like some final formulas, which we will be discussing further in the problem solving session. I won't be like discussing it here. And we also saw what are the other kinds of relationships that can be established between multiple variables. One of them was using the power law, where the relationship is established as y is equal to x bar a, where a can be a constant. It can also be established as an exponential form, where y is equal to a e power mx. So there are different ways to represent this graph, represent all these three relationships. A linear equation can be represented in a normal graph. Normal graph as in where you have x and y planes and x and y's are integers. Power law can be expressed in a log-log graph where both the x-axis and y-axis are in a logarithmic format. An exponential law can be established in a semi-logarithmic form where your x-axis will be in a logarithmic form and your y-axis will be in a linear form. And there's one more relationship which involves representation of two variables using polynomial form, but we also saw that polynomial form does not give much insight into the relationship between two variables. So polynomial form is not generally uh, encouraged in the scientific community. And after that, we saw more about how to develop a mathematical model, and we saw mainly how differential equations are uh, formed while developing a mathematical model. So to develop a mathematical model, first you define a problem, and then you obtain any experimental data from it which can be used to build the model, and then you create the model and then you test the model. So usually this kind of models will be in the form of differential equations. So once you obtain the differential equation, you try to put in data and then see if the expected outcome falls within some given error range. So that's what we saw in mathematical model. And in the final part of the lectures, we saw more about dimension analysis, where we saw how models can be verified. Whatever mathematical model we build, it has a left hand side and right hand side, where the left hand side was to be one quantity, and then the right hand side consists of multiple quantities in different proportions, which added or multiplied together gives us the quantity in the left hand side. So how do we verify this model? Using something called as a dimension analysis. So dimension analysis involves the fundamental concept that the units of the fundamental units of the quantities presented in the left hand side and the right hand side should add up equally. There shouldn't be any differences between the units in the left hand side and right hand side. By units, what we tell is the fundamental units will be mass, length, time, and temperature, which are represented using m, l, t, and theta respectively. So using this four, whatever physical quantity we observe or measure in the universe, that will involve majority of them will involve these four fundamental quantities. Of course, if you see in other books as well, you will find a lot more other fundamental quantities like such as luminosity and all those stuff, luminosity, energy, and all those stuff. But for simplicity reasons and for everyone to get it like from science and non-science and non-math backgrounds, we stick to these four fundamental quantities. And we also saw that this kind of establishing this fundamental relationship between this fundamental quantities would lead us to the formation of phenomenological models. So phenomenological models are something which models which are not entirely developed from theory but are used to validate theoretical perspectives. So that's all I would say, the recap for week 9. So comparatively it was a very short week because there was a lot of derivations and a lot of lectures. So I'll leave the room till 3:15 for a short doubt session. So after 3:15 maybe we can start with the problem solving session for week 9. Till 3:15. Yeah, sure. You can also take up doubts later. Like as always, like I would also having a doubt session after the problem solving questions. So we can start with the problems. So this time I think the problem solving session has 11 questions. Yeah, sure, Nikhil. Thank you for the suggestion. So I'll take this up now itself. So yeah. So I think this time the problem solving session has around 11 questions, and 11 all the 11 questions were clubbed into three main question sets. And I think many people found difficulty solving the second second question set a lot. So we will go over that in the last, because I would want to go from easy to tough, because I think the last question set makes it easier to understand how to solve the second question as well. So we will start with this. So the first three questions are four questions. I think they focus on dimension analysis, so which is a pretty much easier topic. So we'll go with that first. So the force F on object falling through a viscous medium bubble is dependent on the viscosity of the fluid of the material, the radius r, and terminal velocity v of the object. Use dimensional analysis to find the nature of dependence. Assume F is equal to k mu power x r power y v power z. Find x, y, z. So each question is, so first question is x, second question will be y, and third question is z. So we will start this dimensional analysis by establishing the dimensional quantities of each physical quantity. So F we know is force. Force we know is like mass into acceleration. So for mass we have m, and then for acceleration we have meter per second square. So we have L and t power minus 2. So F is units will be dimensional units will be ml t power minus 2, and k is a constant. So they have already mentioned that k is a constant. So for a constant, constant is non-dimensional, so we don't take that into dimensional analysis. It will have 0 dimensions. And for r is the radius. So radius is basically the length from center point. From, if you take a bubble, radius is basically the distance from the center of the bubble to the periphery of the bubble, the corner of the bubble. So that is the length. So r's dimensions will be length. And same for viscosity, for terminal velocity. Velocity is also meter per second, so the dimensions will be L t power minus 1. And viscosity, I think you could have also googled it. So viscosity is nothing but how viscous the nature of fluid is. So viscosity's units will be meter L power minus 1 t power minus 1. So it's basically the force or something per unit area. So we have all the dimensions of the four quantities. So what we have to do now is just put these values, put these dimensional values in the left hand side as well as the right hand side. And k, as I said earlier, k is a dimensionless quantity, so we didn't include. So your f ml t power minus 2 is equal to ks units, which is no dimensions, into viscosity is units power x, and radius is units l power y, and then velocity is units power z. So this LHS can be the same. We can try to add the m, l, and t values in the RHS. So m's values will be x, because there is no other m in l and t. Sorry, velocity and this thing. And this thing L will be y, and because this one in the this thing. Oh, sorry, I think I messed up something here. Yeah, L is actually y minus 1 minus z. So y minus 1 plus z. So I think I messed up here a bit. But t dimensions are minus 1 minus z. So if you equate all of them, you get x is equal to 1, y is equal to 1, and z is equal to 1. So all the dimensions are 1, 1, and 1. So for the first question, they are asking x. So x is equal, answer will be 1. For the second question, they are asking y. Y is also will be 1. And for the third question, z will also will be 1. Yeah. So these are the first set of questions. So does anyone have any doubts in this? And Nikhil, you are right. Yeah. X is equal to 1. Yeah, sure. I'll go on to the next set of questions, but instead of 4, 5, 6, and 7, I'll go with 8 to 11 first, because these questions are easy, and it also helps us to understand how to solve the uh, 4 to 7. So we'll go over 8 to 11 first. So based on the following information, answer the questions 8 to 11. Suppose you are experimenting temperature and resistance dependence, and then we have data such as we have relation R is equal to R naught into 1 plus alpha t, where R naught is the initial resistance at 0 degrees Celsius, alpha is the temperature coefficient, and T is the temperature, R is the temperature resistance at temperature T. So for every temperature T value, they are varying the temperature from 10 to 100 degrees C, and then they are recording the R value. So R will be 60, like it's varying from 16 to 23 depending on what temperature it is. So we have to neglect the uncertainty measurement of temperature, and using the method of least squares, find the best values of R naught and alpha. So we have this experimental data, this between T and R. So using this and using this formula, how will you find out R naught and alpha? So first question is R naught. So R naught, so basically we saw this relationship. If you expand this relationship, you will get R is equal to R naught plus R naught into alpha t. So that is what we will get the relationship as. And the relationship is between R and T. So R will be the dependent variable and T will be the independent variable. So if you put it in the form of y is equal to mx plus b, you will get m as R naught into A, R naught into alpha, and b as R naught. So in this case, since they are asking R naught, we have to find b. So in the lectures you would have seen that there is a formula for calculating b, which is this sigma xi the whole square into sigma yi minus sigma xi into sigma xi yi divided by n sigma xi square minus sigma xi
Lost.
the whole square. Sorry?
Sentence. AV issue.
Nikhil, I can't hear you.
We could hear till that. Thank you.
Sorry, Nikhil, I couldn't hear you properly. Can you repeat what you said? Sorry.
Sir, we lost your last line. Last line. There was an audio disconnect from your side.
Okay,
Can you repeat last line? Thank you.
Sure. So I was just saying that if you expand this formula, R is equal to R naught into 1 plus alpha t, you will get r is equal to r naught plus r naught into alpha into t. So, and the relationship in this question is between r and t. R is here, t is here. So, if you compare it with the equation, linear equation y is equal to mx plus b, you can find out that b is equal to r naught and m is equal to r naught into alpha. So here this first question they are asking R naught. So we will be calculating B. So in the lectures we saw that how we derived and arrived at this formula for B. So for B you will have this formula sigma xi square into sigma yi minus sigma xi into sigma xi yi divided by n sigma xi square minus sigma xi the whole square. So if you like we have to just calculate you like I think you'll all be having a scientific calculator, I'm guessing, else you'll also be using your laptop or phone. So using a simple scientific calculator you can calculate all these values. It's better to use a pen and like it's better to, in my suggestion is it will be better to tabulate all these values and write them one by one in order to solve this question.
Yes.
Yeah, Excel.
Excel is very helpful. If we do it in Excel, na,
Yeah, yeah,
yeah, we tend to make less mistakes. It's easy.
Exactly, Excel is actually very useful. Actually, for the next question, like next set of questions, I would actually prefer Excel than normal hand calculation because, but the only problem I have with Excel is you won't be accessing Excel in the exam, the final exam. That's my only concern. So
Yes, yes.
that is why I would suggest everyone to also try the tablet because you'll be getting a lot of free sheets,
Yeah,
rough
yeah,
sheets. Yeah.
correct, correct.
So I will also suggest you people to try hand calculation and using a scientific calculator whenever possible. Yeah, but I understand the next set of four questions are very very complex. So Excel was the only way by which you can solve the question like, because it went to multiple digits. And I don't know why they kept such complex questions in the first place as well. But these questions were sort of easy, and this will help everyone to. I hope this set questions will help everyone to see how they can answer those questions as well. So we can just so you can consider t as x and then r as y. So you can just square everything, add them, and then add everything. Have all those x, have all the values for xi square and then xi the whole square, and then xi yi. You can for xi yi you will multiply both t and r, and then you will add all of them to form the final value, and then everything else is simply there. Sigma xi is you just add all these x values, and sigma yi you just add all the y values. So if you keep on doing that, you will get r naught value as 14.8533, and yeah, so accepted range would be between 14.80 to 14.90. Does everyone get this?
Hello, sir.
Yeah, yeah, Damodar, yeah, you can go ahead.
So, I was saying that temperature we are going to take X and the resistance we are we are going to take as a Y.
Yeah.
Okay. Yes.
Okay. Okay. So yeah, your R naught value will be around 14.85. So any value between 14.80. They're asking in two decimal places. So 14.80 to 14.80 will be the perfect range. So the next question will be error bar and R naught is. So for error bar also we have this formula in uh, formula during using the lectures, and for calculating the error value formula you must
Hello, sir.
yeah, sure, Damodar.
So please, can you take the previous slide
Yeah, one
just
second.
for
Yeah.
me? Okay, thanks.
Yeah, sure. So yeah, so we also have a formula for calculating the standard error in R naught, and for that we first have to calculate the value of delta y square. So delta y, we know delta y is the error between the actual um, delta yi will be the error between the actual value between uh, whatever m value and b value we have got, and then the delta value. I think we have solved for b already, but we haven't solved for m. So the first thing that we can do actually would be to solve first for m. So I'll just go. I'll just come for the calculation of m in the next question later. But provided that you calculate m, what you will do is you will calculate this delta yi square, delta yi square value, and then after that you will plug the delta yi square in this formula. Like you will have a series of 10 values for all the 10 observations here. So for each x and y, you will have a delta yi, delta yi square. So you will plug all these values, you will add all these values together, you will plug it here, and then you will calculate this standard variance of delta yi, which uses the formula sigma of delta yi square divided by n minus 2. N minus 2 because one is because of the degrees of freedom, and one is another, we are separating one more because of the one-dimensional, two-dimensional representation of data. So n is 10 here, so n minus 2 will be 8. So if we calculate this delta yi square, and then if you plug this here, like you just have to take a square root of this and then plug it in this formula, final formula, which will give you the value of r naught as 0.269. So any value between 0.26 and 0.27 would be like good range. I hope everyone understands this. Like for all these 4 questions, I think it would be a better bet to calculate all the xi squares, yi's, xi, yi's, and then sum them and keep it, so that you can use it. You can just plug them into all the formulas and use it. So the next question is alpha. So alpha, they are asking in the order of 10 power minus 3. So alpha is nothing but we'll come back to that. So we know from the relationship that our m value or slope value is equal to r naught into a. So what we'll do first is we'll calculate that m, which is r naught into a first. For calculating m, we have this formula from the lectures. So provided that we have calculated all these values, you will just plug them into it, and then you will get r naught into alpha value as 0.078. But we need alpha value. So what you will do is you will just divide this value by r naught, which is 14.85, which we got from the last question. So finally you will get alpha value as 5.284 into 10 power minus 3. But they have already kept 10 power minus 3. So in the answer box you need only type 5.284 or 5.28, because they are asking 2 decimal places. So any value from 5.20 to 5.30 will be a good range. And the last question might be like, the last question in this question set might be the most tricky question. The error bar in alpha is plus or minus, they are asking in the range of 10 power minus 4. So similar to how we calculate SB, like the standard error in B, you can also calculate the standard error in M. So the first 2 steps will be similar, and then standard error in M has a similar formula to standard error in B. So you just plug all the values, and instead of the numerator you will have N, and if you plug that you will get standard error in M as 0.004338. But standard error in M is actually, like M is actually R naught into alpha, it's not alpha alone. So to calculate R naught into alpha, like remember last week when we had error calculation and multiplication problems. So we used instead of absolute errors, we took percentage errors and then we solved it. So we already have Sm here, and then we know M value from the last previous sums, and we know SB value. SB value is basically R naught, error in R naught, and then we also know R naught. And R naught into alpha gives us M. So to calculate delta alpha, we have to use this formula from last week's lectures. So here you know every other value except for delta alpha. So you just calculate, plug them into all the values in this formula, and then you just take square roots, put them. So first you will calculate this, and then switch the square root over here to become the square, and then you subtract this whole value here, and then you take a square root to cancel this. and then you finally multiply alpha to the left hand side to get delta alpha. So if you do all this, you will get the delta alpha value as 3.5059, and any answer between 3.0 to 3.1 could be considered as a good range. So 3.05 might be 3.1 or 3.0 also would be a correct answer. This was a bit of a tricky question because I think you have to lose concepts from last week as well. Is it? I hope it's clear with everyone. Sure, sure. Okay then. So I'll move on to the last set of questions. Yeah. So a coil of metal wire has an inductance L as well as a resistance R. You want to measure the impedance Z by applying a sinusoidal voltage V of variable frequency F and measuring the current I. You know the impedance that is given by, they have given a formula for Z, Z square instead of Z. So they have given Z square is equal to R square plus 4 pi square F square L square, and they have given all the formulas for frequency, uh, L conductance, and then R resistance, Z impedance, all the stuff. So they have given this tabulated data between F and Z, and they have to we have to fit this into a line, and then using that we have to find the best fit values for R and L. So you can see that there is a problem in this question. So problem is they have established the linear relationship in the form of squares, but they are asking the values for the original values. So they have given R square, and they have given the values for F and Z, and they are asking the values for R. So the only way to go around is just to square all these values. So you have X. So what you can do is you can put X square. You can create write a table for X square and then calculate all the X square values. You have Y, and then you can calculate all the Y square values as well. And then use that as the main value, X and Y values for this table, and then find the R square value. And then using the R square value, you can just take a square root from R square value to find R. So that's what. So in this relationship, you can find that Y is, if you consider Z square as Y, R square as B, and then F as X, F square as X. So 4 pi square L square will be your M. So we have this formula, Y is equal to mx plus B. So we'll use the same least squares fitting formula, but instead of the normal R value, you will have R square as B. So you will just plug in all the values from the square data, and then you will find R square as 3556.491. So to calculate R value, you will take a square root of R square, and you will get 59.63 as the answer. So any range, any answer between 59.60 and 59.70 would be accepted. So I hope everyone gets this question.
Sir, can you please repeat the second line? Actually, B of R, B multi. I didn't understand that.
No. I'm just saying, it's not by brackets. I just mean what it is. Like it's not like multiply, divide, or something like that.
Okay, sir. So here what?
So by
what
calculating,
are we finding?
by calculating B, we are trying to actually calculate R square, not R. That's what I'm trying to say.
Okay.
Yeah, because this equation, all the variables are in squares form. So we have to find the square value first, and then take a square root, and then find the answer for this question.
Sir, in the second line, what we are actually finding out is R square.
Yes, exactly.
So R square equal to the RHS, that is sigma of xi square, sigma
Exactly.
yi minus and all that. Correct,
Yeah.
sir?
Yes,
okay,
yes.
Clear.
But the only catch here is here let's just say that here they are asking xi square. So you should not take a sum of squares of all these x values. Instead, what you should take is you should square all these values and then take the sum of squares of that square values.
Yeah.
Yeah, then only you get.
Yes.
So
It is not sum. It is not the sigma square. It is sigma xi square.
Yeah,
Clear. Yeah.
Dakshata can do that.
explain the starting from fourth question.
Yeah. Fourth question only I'm explaining. So we have this relationship z square is equal to r square plus 4 pi square f square l square, and then from this question they have also given us a table of f and z, the frequency values and the z values. So f is our independent variable, z is our dependent variable. So they have given us the table, but they haven't given us the square values. They have given us the normal power 1 values. So from this table, we have to apply
So
the
we
value
can
of,
convert it into square now.
yes, you have to convert the whole table into square, and then use that
Okay.
square table as x and y, x and y, yeah,
The figure in x and y.
exactly.
Okay.
Okay, then if you use that as x and y, you will calculate r square value, and then once you calculate the r square value, you have to
Is
calculate,
that using of this formula, the sigma x square one, the sigma x y
yeah,
one,
you have to use this formula for that squared
the
table.
use of the this full formula?
Yeah, exactly.
Okay.
Okay.
Sir, with the formula, one more time explain it, please.
This formula, so sigma of xi square into sigma yi minus sigma xi into sigma xi yi divided by n is the number of observations, which is 10 here, into
The total
sigma,
number of.
yeah, total number of total number of variables, which is 10. Like,
Data points.
Okay.
yeah, exactly, data points, sorry, yeah, okay.
Okay.
X and y
That is
side
the f
points.
value, no?
Yeah, that's the n value.
Okay.
N value, so n value will be 10 because there are 10 data points here. For every x, for every 10 points of f, there are 10 points of z.
Sir, can I simplify it for maybe
Yeah, sure,
some
go ahead.
are, yeah. So what sir is saying is, n means you have conducted some experiment and you have got 10 points, let's say, or 15 points, 15 observations you have noted. So that is
Okay.
actually the n. And you are actually, usually you plot them on a graph and then you are trying to fit some curve, some line, some exponential thing. Okay, so that the n refers to number of observations you have taken. Yeah, thank you, sir.
Yeah, sure.
Thank you.
Thank you so much, Nikhil, for the explanation.
Thank
Yeah.
you, sir.
So yeah, same thing goes for the next question as well. I oh, I don't know where I. Okay, I thought I made the fifth and seventh questions slides as well, but I don't know where I have it. Okay, anyways, but I'll explain the sixth question's answer as well. So yeah, sixth question's answer also goes in the same way, like the one we performed in the R naught into alpha question, question number question number 10. So similar to how we perform. Ashwata, can you take note? I think I'm getting some interference. Yeah, similar to question, how we perform the question number 10 to perform get the value of alpha. Here also we have a bunch of m value is not one single variable, it's 4 pi square L square. So this whole value is m. So using the formula of m, we will calculate 4 pi square L square, and then what we'll do is to find L, we will divide the whole value by 4 pi square and then take a whole square root. So that will give us a value of 0.60. So your range of answers can be anywhere between 0.55 and 0.86. And the same thing, actually I don't have the slides, but the same thing goes for calculating the error values of L as well as for delta L as well as for uh, delta R.
So we have to submit that also. Okay, delta a, yeah.
Yes, delta L
Okay.
and delta R. That will be the fifth and seventh question.
Okay. So how to calculate? Is there a process or slide for that also, or I would?
I'm not sure where I had it. Once again, I just maybe stop presenting it. It's almost similar to how we solve the initial answers as well. But
No problem, sir. If you are anyway going to upload the
MPT, yeah, yeah.
take in the common
Hello.
location, right, sir?
Yeah, yeah, yeah.
Yeah, no problem. So then we will have that, right?
Yes, yes, yes.
Okay, thank you, sir.
So
Actually,
the
yeah, actually, I think a lot of people actually asked doubts last week, but I was kind of busy in some deadline, so I couldn't like answer them on time in the deadline. Yeah, here it is. Yeah. So for error value of r, you use the same thing, but what you do is you take the calculate the value of r, and then you take the calculate the error value for r square, and then you take a square root for it. So ultimately, you'll end up with answer for 0.42, and your accepted range will be between 0.4 and 0.45. Dakshata, you were saying something.
so the error bar
Ah,
of R. Can you explain it 1 second?
so error bar. Okay, rather than explaining through this question, I'll explain through the.
So
Uh,
fifth question, that is error bar plus minus
yeah, yeah, one
R
second.
is plus minus.
So this question, like the 11th question, did you get how we are calculating the error bars?
No, no. So it's question number 5.
No, no, but I'm just asking, did you get how we were calculating the error bars for the question?
No, I missed this.
Yeah. So we have a bunch of values like t and r values, dependent and independent variables. So using that, we also have the error value for r in this r naught. So using this, we have to calculate the error bar in alpha. So for calculating the error bar in alpha, we also have the formula in this lecture series, for which you have to first calculate the delta ya square using this formula given in the lectures. So delta yi is nothing but the deviation of any data point from the actual linear fitting curve. So once you calculate all the deviations of each data point, you will sum them and square them, and then you will plug it into this formula, which is the variance of all the deviations of data points. Which there you will plug this formula, and then you will divide it by n minus 2 by taking the whole summation. So basically, what you are doing later is you are taking the calculating the standard deviation value of m using another formula which was given in the uh, lectures, which is given by standard deviation of delta y into square root of summation of n divided by n summation of xi square minus summation of xi the whole square. So once you get that, you will get this value called 0.004. But this standard 0.004 is the standard error in m, and we want m, we know that it's r naught into alpha, and through last class we know that if we have multiplication of two values, the error will be represented in percentages, relative errors and not absolute errors. So we have to use the formula from last week for calculation of the delta alpha, which is the actual error bar in alpha. So you will get 3.059. So for even the fifth question, we will be doing the same thing. One second. So for the fifth question, you will be doing the same thing as well. So I have asked you to, for the fourth and sixth question, I have asked you to calculate the square values of f and z. So what you will be doing is, after calculating f and z, f square and z square, you will be having that table, and you will be using those f square and z square values as x and y. So what you will be eventually doing is, you will be plugging those values in this formula, and then for calculating the delta ya square, and then the usual thing, you will find the variance of the delta ya, and then you will find the standard deviation of b value, which is the r square value, which is around 0.42. And then what you will do is, you will use the formulas from last week to find out the derivative part of this thing. Actually this value will be 0.001016 or something, and 0.42 is the final answer. 0.016 would be the value of SB. From that, what you'll be doing is you'll be calculating the error value of R through the derivative equation from last week.
Sir, can you please repeat what is the actual value? I think it's a typo you said, na? So SB is coming out to be
SB will come around to be like 0. Exactly the like square of this, square or root 2 of this.
uh, okay. Okay.
Yeah. So if you use the derivative formula from last week, where
Uh-huh.
the delta z by z will be root 2 into.
Yeah, yeah, yeah. Sir, what I wanted was as a what middle step check whether we are proceeding. So while we do it, so SB's value was, even you can tell approximately for whether we are on right track. So SB is coming out to be approximately, you said.
SB's value will be approximately 0.16, something like that.
Okay, okay, clear. Okay,
Yeah.
okay.
1 second. Yeah. So same thing goes for question number 7 as well. Question number 6 we already saw. We just have to take the value of 4 pi square L square, and then using that we have to find L. So error bar in L will also be similar. So we have to use that same formula from this thing, and then you will find delta L as 0.011. I'm sorry, my PowerPoint is glitching a bit, so I don't know, I can't show everything on my screen.
Sir, we can see right now. Yeah, it's all right. So PowerPoint we
Yeah,
can, but on the right side we can see the green tick with 0.01 to
yeah,
the
yeah, yeah.
range.
That is the
It
answer
is
range.
visible. It
Yeah,
is visible.
yes, yes. So eventually that's what matters, and your delta L will be around 0.011. Like that's what I got. I got 0.011.
Yes, sir. That L is not visible right now.
Yeah,
Some problem.
yeah. I don't know. My PowerPoint is glitching today. Yeah.
Okay, okay.
Anyways, so
Sir, maybe
let's.
you can stop presenting and restart. Then problem will go. Usually I do this
Yeah,
whenever.
yeah, yeah. I'll just try that once. Yeah, I think it's still making some problems. Maybe I just restart my whole system. Yeah. Yeah. So, anyways, that's all the doubt sessions for today's lectures. So, after this, I think we'll just be having a doubt session. So, if any of you like, I'll leave the room open till 4. If any of you have a doubt session, please feel free to shoot it up.
Sir, just two, three questions
Yeah,
because
sure, sure,
thank
sure.
you very much. These are generic. So from this, what when we are doing it with you or under the guidance, it is okay. But in the exam, are the uh, problems going to be so difficult?
No, no,
Because
no, no. I don't actually. I don't think so. The problems are going to be as difficult as this square thing, but
yeah,
you can expect the previous set of questions that we were seeing, right?
yeah,
Regarding the temperature and alpha coefficient.
yeah,
So
yeah.
those kind of problems, I think we can expect, because those kind of problems, those are not going to take like even we if we do like hand calculations. I don't
Okay.
think we are going to take more than 20-25 minutes for the
Yeah,
question.
yeah, 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 yeah. And sir, actually, I'm frankly not going through the lectures, but I'm going through sir's book, research methodology for. I think he has taken it from that only, right?
Okay.
So the next after this, next two three chapters are theoretical. Am I correct?
Yes, yes, yes. All
Ah,
the like from week 10, I think it's just writing CVs and ethical issues and
yeah, yeah, yeah. And on that also there
quizzes.
will be questions in the exam, right?
Yes, yes.
Something at least.
You'll
Yeah.
be having questions from almost all the weeks.
Okay.
Maybe the initial 2-3 weeks were like almost like history based. So I think you can expect lesser questions from there.
Okay, okay,
I think the majority of the questions you can be facing from the based on central limit theory, finding your standard
central limit.
deviations and standard errors.
Okay, okay,
Yes,
clear.
because those kind of questions I think they can be easily solved if you have a calculator. This
Yeah, yeah,
dimensional analysis based questions as well.
yeah, yeah.
Yes,
Okay, thank you, sir.
yes. S- Obek James, okay. Vijay, okay. Your question number one, right? I'll try to reshare my screen once again. Hopefully it goes well this time. Okay. So we have this formula f is equal to k into nu power x r power y v power z. So we want to know how we came to x is equal to 1. So first what we do is we just list out all the dimensions for all the physical quantities. So automatically our f force is like mass into acceleration. So we will have mass as m, acceleration is l into t power minus 2. So it's this thing. Um, and r is the radius, so it is just l. V is the velocity, so it's meter per second, so dimensions will be l t power minus 1, and then your viscosity dimensions will be m l power minus 1 t power minus 1, and k is a dimensionless quantity because it's a constant, so it will not have any dimensions. So now what we do is we just try to equate LHS and RHS. So on the LHS we have f, which has ml t power minus 2, which is equal to a dimensionless quantity k, and then viscosity is units m l power minus 1 t power minus 1 into x power x, and then l power y, and then z power l t power minus 1 power z. So what we do is we now club all the m's, l's and t's from the RHS and then club them together. So we will have m power x because only for this viscosity as m, and then we have, actually here there's a typo, it should be l power minus x plus y in plus z, but I have put only y. But yeah, but nevertheless the minus x and z will cancel each other, so it will be y only. So t is minus x and then minus z. Yeah. So eventually what will happen is you will equate x will be 1, and then you will plug everything inside, and you will solve the equations, and you will get value as x is 1, y 1, and z as 1. Sure. So yeah, so uh, if anyone else has any doubts till 4, we can discuss. Yeah, and I'll leave the room open till then.
Sir, explain the last one question. So, those who recently explain it.
Sorry, which one?
The last one.
The first question. This question.
Yes.
Yeah, so I mean, we are just doing dimensional analysis. So what we're doing is we are using the dimensions of each of the physical quantities, and then we first get all the dimensional quantities of f, r, v, and yeah, we just get all the dimension quantities of f, r, v, and v, and k, since it's a constant, it will not have any dimensions. So what we do is we equate the dimensions of the quantities in the left hand side as well as the right hand side. So ultimately what we'll be doing is we'll be adding all the dimensions from the right hand side, and then finally when we equate it, we will get x1, y1, and z as 1.
So we assume it only one value.
No, no, we are not assuming anything. We are calculating the values. We are calculating and finding the values. See
So
here,
every value is only one, no?
yes. So see here it is m power 1 is equal to m power x. So x should be 1. And here L power 1 is equal to L power minus x plus y minus x plus y minus plus z. So your minus x plus y plus z will be 1, and then t power minus 2 is equal to t power minus x minus z. So your x plus minus x minus z will be equal to minus 2. So you solve all these equations and then you will get x1, y1 and z1. Actually, there is a typo in this expression. I have to change it. But eventually, what you'll get is x1, y1 and z1.
Hello, sir.
Damodar, yes.
Sir, I'm not able to understand this the second last line in which the t raised to power minus 1 minus z. So,
No, no,
can
no,
you
wait.
please?
I'll change it right away and just give me 2 minutes. I'll just change this right away and then I'll show it to you. So L will be minus x plus y plus z. Minus x minus z will be minus 2. So this is equal to 1. So minus x plus
Sir, question number 2. Can you repeat it? I think I missed it.
one second. I'll just come back to this. So yeah, now I have now I have rectified the expressions. So we'll be having this expression in the end if we add up sum up if we sum up all the dimensional equations. Uh,
Sir, एक minute. Yes, sir.
Yeah, so this is for the first question, not for the second question actually. So in the first question, we have this MLT power minus 2 on the left hand side, and then we have all this dimensional quantities on the right hand side. So if we add up all of this, we have m power 1 is equal to m power x on this side. So x will be automatically 1, and if we take L power 1 is equal to L power minus x plus y plus z. So uh, forget L
Sir,
for
one
now.
more time.
Okay, so we have, so here you have m power 1, here you have m power x. So powers, if you
Sir,
equate,
the
sorry,
screen will, the screen is not visible.
is the screen not visible for everyone?
It is visible. It is visible. Yeah, I can
Sir,
see
now,
your pointer.
sir, now it will be visible.
Okay. So yeah, so basically you equate the powers and then you will get x is equal to 1 automatically. For t, you have t power minus 2 is equal to t power minus x minus z. So if you equate the powers, you will get minus x minus z is equal to minus 2. You already know that x is equal to 1. So substitute x is equal to 1 and then you will get as z is equal to 1. And then for the last L, you will have L power 1 is equal to L power minus x plus y plus z. So minus x plus y plus z is equal to 1. You already know x and z as 1 and 1. So you substitute all of them, both will cancel each other. So you'll get y is equal to 1. So x is equal to 1 is the answer for the first question. Y is equal to 1 will be the answer for the second question. And z is equal to 1 will be the answer for the third question. Saurabh, so value of z will be 1 only, not 2.
So value of y is equal to is
value of
No,
y is
it
1.
means 1, 1, 1.
Yeah,
So for all three, it is 1.
1.
1, comma 1, comma 1. That is what sir means, I think.
Yeah.
So he has just written.
So
So
so it
in
will
the
be so in the end it will be f is equal to k into mu power 1 r power 1 v power 1. So that's what you have to answer for the in the subsequent questions. So in the second question they are asking y. So y's answer will also be 1. And in the third question they are asking z. Z's answer will also be 1.
Okay. Thank you, sir.
Sure. Yeah, sure. Thank you. Actually, like we will end the session right away as well. Question number 9. So question number 9 answer is question number 9 answer is 0.269. And valid range would be around 0.26 and 0.27. Okay then, so if no one has any questions, we will end the session right now. I once again thank you for your doubts and the interesting doubts you posed. And the next session will be in the next Saturday, which is 30th March. Same timings, 3 p.m. to 5 p.m. So we'll meet then. So until then, see you. Thank you.
Sir, it will be available on portal, na sir, this session?
Yes, yes, this portal will be it will be available in the problem solving assessment tab. So as a
From tomorrow or today itself?
so I'll try to upload it by
It's
today or
Monday, na?
I'll try to upload it by today or tomorrow. So the recording it depends on when I upload the recording actually. So I'll try to upload it by today or tomorrow. As soon as I upload it, it will be available. Yes. So as soon as I upload it, it will be available. Yeah. So yeah.
Thank you, sir.
Thank you. Thank you.